Hi everyone, we are still on the topic forces and motion for mechanics. We started by looking at Newton's first law of motion, and we solved some problems under that first law of motion of Newton. Today we are going to look at Isaac Newton second law of motion, and we'll try to solve one or two problems under that topic. The second law of motion, Newton's second law, is what we're going to be using mostly on this topic. The third law, with Newton's, there are three laws of motion by Newton. We're only concerned with the first two. The third one, I don't think we're going to use it under this topic. It's for people doing physics. So what does the second law say? The second law states that Newton's second law states that the force needed to accelerate a particle, the force that is needed to accelerate a particle is equal to the product of the mass and the acceleration produced. That is what the second law says. In other words, the force that is required to accelerate a particle, that force F, we say, is equals to the product of the mass and the acceleration that is being produced. So F equals ma. That is Newton's second law of motion. The third law, which is not required here, simple. It says action and reaction forces are equal and opposite. We already mentioned the first law, which says that every body continues in a state of rest or in motion except impelled by some external forces that will make it to act otherwise. So these are all the three laws of motion. So after stating the second law of motion, this is what we need. F equals mass times acceleration. Just you require this formula. Now we have a problem here to solve. The problem says the force P acting on the body causes it to accelerate as shown. That is as shown here in this diagram. We are now asked to find the magnitude of the force P. This is a body of mass 2 kilograms, or a particle of mass 2 kilograms. And we are already shown the two forces acting on it. One is going upwards, that is the normal force. And we have one is acting downwards here, 2g newtons. This N is a unit of force, Newton. And this is the weight force. The 2 kilograms here is the weight of the particle. Down here you have it multiplied by g, that is acceleration due to gravity. It's now transformed to a weight force. And we are given the acceleration as 3 meters per second squared. So we are asked to find the magnitude of this force P. It's simple. As long as you know Newton's second law of motion. So we already know that the net forces for a body to be in equilibrium, the net forces, all the forces acting on it, the net forces must be equal to 0. All right? So here we see in this diagram, acceleration is pointing upwards. It means this particle here is going towards the direction of P. It's going towards the direction of P. So what will be our net force here? It's accelerating. So then we'll have P minus 2g. This g is acceleration due to gravity. It's a constant. It's given to you. G is 9.8 meters per second squared. Some books, they say g is equals to 10 meters per second squared. So it depends which book you are, or what the question indicates, asks you to use. But mostly the book we are using is Edexcel Statistics and Mechanics, Edexcel AS and A-level mathematics. So they use 9.8 meters per second. So we stick with that. 9.8 meters per second. Alright? So times g, this g here is 9.8 meters per second, must be equal to, that is, we are saying now, this net force, P minus 2g, because it's accelerating. The particle is accelerating, is going up. So this force here must be greater than this. That is why we are subtracting this from this. If it was decelerating, yeah, these arrows we are going down, then we are going to subtract this from, we are going to subtract this from this. If this arrow was going down like this, and we are told 3 meters per second squared, this arrow was going down like this, it was going to be 2g minus p. But because the arrow of acceleration is going up, it's telling us the object is going up, it's accelerating. So this force must be greater than this force here. The normal force must be greater than the weight force. That's what we have just done here. And the net force of this is equal to the mass, Newton's second law of motion, mass times acceleration. Yeah? Mass times acceleration. Good. So this is acceleration of the body. Don't get confused. Acceleration due to gravity, which is g, and the acceleration of the body. The particle itself, it has an engine accelerating, you know. So g and a, don't get them confused. The one acceleration here is a constant acceleration due to gravity. This is acceleration of the body itself, or the particle itself. So you have P minus 2 times 9.8, 2 times 8, 16, 2 times 9, 18, plus 1, 19.6 equals, the mass we know is to be 2 kilograms, and now the acceleration of the body is given to us here, which is 3 meters per second squared. So that's what you have. You are applying Newton's first law of motion. Force equals mass times acceleration of the body. You got two forces here, you got to find the net force. Yeah. So P minus 19.6 equals 2 times 6, 2 times 3, sorry, is 6. We shall bring the units later. So P therefore is equals to 6 plus 19.6, which is equals to 25.6. Newtons. We are looking for force. This is 25.6 newtons. All the time. Thank you for watching. I hope this explains well. Thank you.